Hey everyone, and welcome back. So, in our previous video, we explored the art of data pre-processing and preparing our data for analysis. So, today we are venturing into the exciting world of machine learning with a fundamental technique called simple linear regression. So, the simple linear regression is a, statistical method that models the relationship between two variables by fitting a linear equation to observed data. So, one variable is considered to be an independent variable, and the other one is considered to be a dependent variable. So, this is the equation that we are using for simple linear regression. So here y hat is the dependent variable. Uh, this x1 is the independent variable. This b naught is the intercept of the line that we draw for this equation, and here b1 is the slope of that line. So let's take a real example and understand this simple linear regression in more practical manner. So let's say we want to determine if there is a linear relationship between the amount of fertilizer used and the potato yield. So in other words, we want to see if we can predict the potato yield based on the amount of fertilizer applied. So first of all, we have to gather data on the amount of fertilizer used and the corresponding potato yield. So for an example, here you can see for 10 kilograms of fertilizer, we can get 1.2 potato tons. Likewise, for different amount of fertilizers, there is different amount of yield. So now we can plot the data points on a scatter plot to visualize the relationship between the fertilizer amount and the potato yield. So here the potato yield is measured using tons and the fertilizer amount measured using kilograms. So here we can change our simple linear regression equation according to our example. So the x here, x1 here is the amount of fertilizer that we are using, and the y hat is the potato yield. So after applying this simple linear regression algorithm, we can find the intercept and the slope of this equation, that means b naught and b1 values. So for that we have to draw the best fit line that goes through these data points. So after that we can use some statistical methods to calculate the values for this intercept and slope. So for the moment, let's assume the intercept here, the intercept is 8 ton, and the slope is 3 tons per kilogram. That means the increment of 1 kilogram of fertilizer can increase the potato yield by 3 tons. So now you may think how to find the best fit line that goes through these data points. Yeah, that's a good thinking. So it's possible to draw multiple lines that goes through these data points. So to find the best fit line, we are using a method called least squares method. So in the next video, we will see what is this least squares method. So until then, bye bye.